So if the double angle formulas were not enough for you, we also have half angle formulas, which we'll focus on here. And so we can see that there are separate half angle formulas, of course, for sine, cosine, and tangent. This time it's tangent that has multiple variations of the formula. You'll notice that they have a plus or minus in front of them, all the ones that have a square root in them. The tangent half angle formulas that don't involve the square root, you don't put a plus or minus in front of it. And so the plus or minus does not mean that you're going to get two answers. Like when you take the square root of both sides of an equation, we put a plus or minus in front of it. It means that we are going to have to choose whether our answer is positive or negative depending on where that half angle ends up. And we'll see that in our examples, that we're going to have to make an affirmative choice as to whether the answer to the sine or the cosine or the tangent is positive or negative for each individual question. So we're going to start similarly to how we did previously with the double angle formulas. So in the example here, we've got to draw a triangle because we're given some information where the sine of x is 4/5, but we can see above that we need to know what the cosine of our angle is in order to be able to use these formulas. So I'm going to draw a triangle, and a key element of the information is knowing where the original angle is located so that I draw the triangle in the correct location. So for this one, we're told that x is in the first quadrant, so that makes life a little bit easy for us. So up here, I'm going to go ahead and draw our triangle just to kind of keep it out of the way. And so we're told that the sine of our angle x is 4/5, so opposite over hypotenuse, 4/5. So hopefully we recognize this as a 3, 4, 5 triangle, so that adjacent side is 3. And so that means that the cosine of our angle x is 3/5, adjacent over hypotenuse. And so that's going to be what we're going to use when we plug it into each of these half angle formulas. So if we start off with the sine of the half angle, so sine of 1/2 x is going to equal the square root of 1 minus cosine, so 1 minus 3, let's try that again, 3/5, and then that's all over 2. And that 2 is also underneath the square root symbol, as we can see back in the original formula. And now we have to decide whether our answer is going to be positive or negative. And so it might be easier for us to think of this as being x is between 0 and 90, rather than thinking of it in radians. So if x is between 0 and 90, that means that 1/2 x, the half angle, is going to be in an interval of 0 to 45. So if I take a number that's between 0 and 90 and multiply it by 1/2 divided by 2, I'm going to get a number that's in that range. And so that means that my half angle is in the first quadrant as well. If my original angle is in the first quadrant, in this case my half angle is in the first quadrant, which means that the sine of that half angle is going to be positive. That's also going to be true for the cosine and for the tangent. Everything is positive if it's in the first quadrant. So that's why I'm going to treat my answer as being positive. Now I'm not normally going to write that as being a plus, I'm just going to leave it, but I just want to make sure that we understood that our answer is positive here. And so now the remaining work that I've got to do is I've got to simplify this expression. I have a couple of issues. I have a fraction within a fraction, and I've got a square root in the denominator, since that 2 is underneath the square root symbol as well. So I'm going to approach this by first subtracting 1 minus 3/5. So I've got the square root of 2/5 divided by 2. So now I've got to take 2/5 and divide it by 2. Or 2/5 times 1/2. Well, 2/5 divided by 2, or 2/5 times 1/2, is going to clean up into the square root of just 1/5. And so now we can rationalize this answer, multiply the top and bottom by the square root of 5, and so we get root 5/5 as our answer for the sine of the half angle. If we want to do the cosine of the half angle, well, cosine of 1/2 x is equal to, we can see it up above, and again we've established that our answer is going to be positive because 1/2 x is in the first quadrant just like x is. So we're going to have 1 plus 3/5 all over 2. And so now we can add 1 plus 3/5 up in the top. So 5/5 plus 3/5, we get 8/5 over 2. And so if I take 8/5 and divide it by 2, or 8/5 times 1/2, we're going to get the square root of 4/5. Now in this one, we can multiply the top and bottom by root 5, but first we can take the square root of 4. We can split it up and take the square root of 4 up in the top, and we get 2 over root 5. And so now when we multiply the top and bottom by root 5, we get 2 root 5 over 5. So there's our cosine of the half angle. And so now in this case, just like we did with the double angles previously, we can go ahead and just divide these answers, take the sine divided by the cosine, and get our result that way. That will work out pretty nicely for us, so we can go ahead and do that. So our tangent of the half angle is going to be equal to the sine of the half angle divided by the cosine of the half angle. So I'm going to take root 5 over 5 divided by 2 root 5 over 5. So I'm going to rewrite this as a multiplication question. So root 5 over 5 times the reciprocal of the bottom one, so times 5 over 2 root 5. And we can see we've got a true cross-canceling bonanza here. So I can cross-cancel the root 5s, I can cross-cancel the 5s, and so then we end up with an answer of 1/2.